our first friendly mock, exam 1. Try to realize calculators may not be used on this part of the exam. This one's 30 questions. 30 questions in all, and we're going to try to do it without a calculator as quickly as we can. It's a limit problem. This is the limit definition of the derivative. So I'm just going to take the derivative of sine x at pi over 2. So the derivative of sine x is cosine x, and I'm going to plug in pi over 2, and cosine of pi over 2, going to unit circle, is going to be 0, 1, so this one should be 0. Choice C. Number 2, position function. Find the velocity at t equals 1. So what I'm going to do is, I'm going to FOIL this out. I'm going to make a big pun it, and go ahead and FOIL it. Distribute the negative across that, and make it negative t cubed plus 2t. Then write this down, t squared minus 2t plus 4. Notice I distribute the negative across the second quantity. Then I'm just going to multiply this, and then take the derivative of it and plug in t equals 1 to find the derivative at t equals 1. 2t to the 4th, negative 4t cubed, 2t cubed, they will combine, negative 4t squared, and 8t. When I combine my terms, that's going to give me negative t to the 5th, plus 2t to the 4th, minus 2t cubed, minus 4t squared, plus 8t, and I'm going to take the derivative of this, evaluated at t equals 1. Position, what is the velocity? So quick pop the derivative, that's going to give me negative 5t to the 4th, plus 8t cubed, minus 6t squared, minus 8t, plus 8, and I'm going to plug in t equals 1, so it's not going to change the values of any of these, so it's going to be negative 5 plus 8 is 3, minus 6 is negative 3, and 8 minus 8 cancels out, so my answer is negative 3, and that should be choice A. X is shown above. The function is twice differentiable, so that means it's continuous and smooth. F of 2 equals 4, which the following is true. So let's see here. This is the derivative. This is the derivative. Let's see what it says here. This is a drawing of f prime, and it says f of 2 equals 4. So this is going to be my f. So f of 2 equals 4. And notice, this here is decreasing. It's positive. Goes through 0. That means this here is going to either be a max or a min. And then it's negative. So if it's positive, that means this is going to be increasing. And then when it's 0, the slope is going to be 0. And then because that's negative, it's going to be decreasing. So that's a max. Now, for f double prime, let's see. F double prime. Where this is 0, that's a max or a min. This is constantly decreasing, and this is constantly concave down. That's the key. Because this is concave down, this is going to be negative the whole time. It's going to be negative. Because that 0 there, I don't know. I'm just going to say that this is going to be negative the whole time. So from this sketch, because this has to be negative, because when the second derivative is negative, that first function is concave down. From least to greatest, it's going to be f double prime of 2 is smaller than f prime of 2 is smaller than f of 2. So let's see which one fits. F double prime is smaller than f, so it must be choice B. Must be choice B. It's continuous from 0 to 6. Which of the following could be the value of B? Not that big of a deal. So that means when x equals B, you want these to equal one another. So 1 plus e to the negative 2, and I plug a b in for x, has to equal 1 plus e to the 2, plug a b in for x, minus 12. Notice the 1s will cancel out. That gives me e to the negative 2b equals e to the 2b minus 12. I can ln both sides, and I'll get negative 2b equals 2b minus 12. Now it's just a simple pre-algebra problem. Negative 4b equals negative 12. And so b is going to equal 3. At b equals 3, these two will be continuous. And there it is, choice C. I have to know a little bit about inverses. So it has f of x and g of x. And wants to know g of x is the inverse of this, and what g prime of negative 8 is. The only way I can do this is if they ask g prime of negative 8. Because this graph, f of x, goes through 0, negative 8. So I'm not supposed to have graph paper, but I'm going to call that 0, negative 8. Now the inverse of that will have a point at exactly negative 8, 0. I don't know what this curve is going to look like. Well, I do know what this curve is going to look like. It's going to be a cubic. It's going to be a cubic. I'm not allowed to graph it, though, because I don't have a graphing calculator. I'm not going to graph it by hand. I'm going to take the inverse of it, though. And that there is y equals x cubed minus 6x squared plus 12x minus 8. And notice, because of that minus 8, I know it goes through 0, negative 8. And its inverse must go through negative 8, 0. I'm going to take the inverse of this. In order to take the inverse, you flip-flop the x and y. So this is going to be x equals y cubed minus 6y squared plus 12y minus 8. And they want to know what the derivative at 8 is. So I have to take the derivative of this. Well, the derivative of x with respect to x is 1. The derivative of y cubed is 3y squared, y prime, this is an implicit problem, minus 12y, y prime, plus 12, y prime, and then the derivative of negative 8 is 0. Now, I'm supposed to plug in for all the x values -8. And all the y values 0. And that is where knowing that the flip-flop of this was -8, 0 helps. Because there's no place to plug in a -8 into this. But I can plug in a 0. I can plug in a 0. In order for me to do that, though, I don't want to plug in the 0 now. I'm going to solve this for y prime. So I'm going to factor out a y prime. This is going to give me 1 equals 3y squared minus 12y plus 12 times y prime. And then, because I factored out a y prime, and then I divide both sides. So that gives me 1 over 3y squared minus 12y plus 12 equals y prime. I'm going to plug in a 0 for all the y's and a -8 for all the x's, but there's only y's. So that's going to give me y prime equals 1 over 12. And there it is, choice C. Circular rubber band. It's probably got a radius. Shape of the circle is evenly stretched, and its radius is increasing at a constant rate. So dr dt equals 1.5, positive, 1.5 centimeters. At what rate is the circumference? So they want to know what dc dt is of the rubber band changing when r equals 6 centimeters. So this is what we're looking for. So c equals 2 pi r. We'll take the derivative of this, so that's going to give me dc dt equals 2 pi. The derivative of r with respect to t is dr dt. I guess I don't need the r equals 6. That was a distractor. But dr dt equals 1.5. So dc dt is going to equal 2 pi times 1.5. And that's going to give me 3 pi. And there it is. Choice B, 3 pi. Number 7, a limit problem. A lot of limit problems. You notice it's limit as x goes to 0. So I'm supposed to take that 0 and plug it in. Well, tangent is 0 from the unit circle. Tangent of 0 is 0. So that's going to give me a 0 on the bottom. I'll just write it over here. 0 on the bottom. And then cosine of 0, I believe, is 1. Cosine of 0. Cosine of 0 is 1. But ln of 1, ln of 1 will give me 0. Minus e to the 0 is 1. Plus 0. I'm plugging in 0 for x. Plus 1. So that's going to equal 0 over 0. Indeterminate form, so I'm going to implement L'Hopital's rule. So I'm going to take the derivative of the top and the derivative of the bottom. Well, the derivative of tan x is secant squared. Remember secant, tan, this is going to be helpful, this note. So the derivative of tan is secant or secant squared. So that's going to go on the bottom. And cosine x. The derivative of ln cosine x is going to give me 1 over cosine x. Then I have to take the derivative of cosine, which is negative sine. And I put that on top here, which is tangent, I believe, negative tangent. And plug in 0. Well, as we saw before, tangent of 0 is 0. E to the 0 is 1, but it's going to be negative 1 plus 1 equals 0 over 1. So this limit goes to 0. Let's see if that's therefore. Yes, it is. Choice A. Choice A. Y equals x squared. I know I'm not allowed to use the graph paper, so let's go up 1 over 1, up 1, 2, 3 over 1, up 1 over 1, up 1, 2, 3 over 1. So it's going to look like that. And then I have 2y equals x squared plus 4, and divide everything by 2. So it's going to give me y equals x squared over 2 plus 2. So this one's going to start at 2. I'm going to use my 1, 3, 5, 7. But I put 1/2 out in front of it because I have a 1/2 leading coefficient. That's going to give me 0.5, 1.5, 2.5, so on and so forth. So from here I go up 0.5 over 1, 1.5 over 1, and I notice that's where they intersect. That's where they intersect. This graph, lower graph, is x squared. This upper graph is 1/2 x squared plus 2. Now this is tricky. It says it's revolved about the line y equals 4, which is right up here. That's the line that I'm revolving around. So this is going to be the integral from, they intersect at -2 to 2 on the x-axis. So from -2 to 2 of the outer radius squared. And this outer radius is this line 4 minus x squared. 4 minus x squared. Squared. Minus the inner radius. And this inner radius is 4 minus 1/2 x squared plus 2. 4 minus 1/2 x squared plus 2. That whole quantity squared with respect to the x-axis. Now I have to test and see which one of those matches this. Cannot be it. Too abbreviated. Choice B, ooh, nope, no 4. No 4, they forgot the 4. Choice C, well there's the 4 minus x squared. But there's no 4 here. It's the 4 minus x squared, but there's no 4, wait a second. 4 minus 2. 4 minus 2 is 2. This has to be choice C. This has to be choice C. Time is the water being pumped at the fastest rate. Okay, so let's inspect this. This is a cube. This is a cubic. Negative t cubed. Negative t cubed. So a negative t cubed, a positive t cubed, x cubed would look like that. So a negative t cubed is going to be up on the left, down on the right. So I have a low and a high, and this here is where it's being pumped at the fastest rate, okay? So I'm just going to take the derivative of that and set it equal to 0. And that will either give me a min or a max. So the first one's going to be a min value, and the second one's going to be a max value. So the derivative of that is negative 3/4 t squared plus 3t. And I set that derivative equal to 0 to find out where the maximum pumping capacity is. I can factor out a t. So it's going to give me t times negative 3/4 t plus 3 equals 0. I'm going to implement ZPP, the zero product property. I set that equal to 0, and so that gives me t equals 0. That could be one of my, that's not an answer. That's not an answer choice. All right. Another answer is where I set this equal to 0, so that gives me negative 3/4 t plus 3 equals 0. I subtract 3 from both sides, so that gives me negative 3/4 t equals negative 3. Multiply both sides by 4. I'm going to multiply both sides by negative 4. And that's going to give me 3t equals 12. Divide both sides by 3, and that gives me t equals 4 as my other answer. So 0 would be a min, and 4 would be a max. So it has to be at t equals 4 seconds. Choice C. E to the xy plus 1 equals 3. Take the derivative of that and plug in a 1. That's what that says. Both sides. ln both sides. That's going to give me xy plus 1 equals ln 3. Subtract 1 from both sides. That gives me xy equals ln 3 minus 1. Solve Mr. Y. Y equals ln 3 minus 1 over x. Now I'm supposed to take the derivative of it. Y equals ln 3 minus 1 times x to the negative 1. This is just a constant. This is a digit. So I brought that out to do general power rule. It's going to give me negative, parentheses, ln 3 minus 1, x to the negative 2 at x equals 1. I plug in a 1 there. 1 to the negative 2 is 1. So y prime at x equals 1 is going to equal 1 minus ln 3. Choice B. The equation of the perpendicular to the curve at... So I have an x value, I have a function. So when x equals 1, I plug in 1, that's 1 plus 4. 1 plus 3 is 4. The square root of 4 is 2. Now I need a slope. So I take the derivative of that at x equals 1. So the derivative of square root x cubed plus 3, the derivative of that is going to give me 1 over 2 square root x cubed plus 3. Then I take the derivative of the guts, which is going to give me 3x squared at x equals 1. Will give me the slope. So I throw in a 1 there, that gives me 3 over 2 times square root 4 equals 3/4. But that's the slope. I need the perpendicular slope, because it's normal line. So the perpendicular slope is going to equal the negative reciprocal of that. Now I guess I need to write this in the form of equation of a line in like standard form, I guess. Not even standard form, because they lead with the y in each of these cases. So I'm going to use y minus y sub 1 equals m times x minus x sub 1, where this is x1 and this is y1. So y minus 2 equals negative 4/3. Y minus 2 equals negative 4/3 times x minus 1. I'm going to clear out the fraction to 3. So it's going to give me 3y minus 6, and multiplying the whole thing by 3. 3y minus 6 minus 4 times this would give me negative 4x plus 4. Add 4x to both sides. That gives me 4x plus 3y. Add 6 to both sides equals 10. 4x plus 3y equals 10. 4x plus 3y equals 10. Choice A. Equal 1 plus 1 over x. Take the derivative. Du equals 0. 1 over x, I can rewrite that as x to the negative 1. That's going to give me negative 1 over x squared dx. I notice that this will simplify with 1 over x squared, but a negative has to go out front. And I have the u world now. This is going to give me an integral with a negative out front of u to the negative 2 du. But if I want to stay in the u world, I have to change my limits of integration. I have to change them. I can't leave it as 1 and 2. So when x equaled 1, u equaled 2. When x equaled 2, u equaled 1 plus 1/2. So now I'm going to take the integral of that and leave the limits of integration, because I changed them. This is a tricky problem. So the antiderivative, I add 1, so it's going to give me u to the negative 1. Then I divide by that negative 1. Don't forget I have a negative out front, so this is going to give me, when all said and done, 1 over u. From 2, you can rewrite 1.5 as 3/2. Now I'm going to plug that in. So 1 over 3/2 is the same as 1 over 3 divided by 2 minus 1 over 2. That's going to give me 2/3 minus 1/2. 6 on the bottom. 4 minus 3. This equals 1/6. And it's choice B.